Hey, welcome back to Math with Patrick. Today is March 12th. We have problem number 71. We're going to solve it today together. So, like always, today's date, the 12th, is going to be the answer to the problem. Find the maximum area of a rectangle whose sides are natural numbers and the perimeter is 14. All right, some definitions. Natural numbers. These are ones that are going to be whole numbers starting at 1. So 1, 2, 3, and so on and so forth. Perimeter just means the total distance around a shape. And well, I'm pretty sure you know what a rectangle is. And so I think I'll just write or draw a table where I'm going to have the length, the width, the perimeter, and the area of any of the rectangles. And I know it says natural numbers, and natural numbers, there's a little dispute whether or not it starts at 0. In previous videos, I started it at 1, but this is going to be kind of a short video. I can already kind of tell that this will be pretty easy. I'm going to start with 0. So if the length is 0, that's a bit weird. My rectangle is no longer a rectangle right now. This is just like a straight line. But you can kind of think that the width is going to still be 7, because if you pretend that the rectangle has 0, 7, 0, and 7 as the side lengths, it will still have a perimeter of 14. Of course, the area is 0, because to find the area of a rectangle, you just do length times width. Though if we have 0 times 7, again, that's just a line. There is no area there. It's a two-dimensional object. Or sorry, one-dimensional. It's not even a rectangle. Okay, bringing up the length to a 1, the perimeter is still 14, because it just has to be, because it says the perimeter is 14. And I'm going to knock down the width by 1. So this rectangle is going to look like 1 by 6. And so I still have a 12 plus a 2, or a 14 as the perimeter. And here my area is 6, because I'm doing 1 times 6. So I could do 2 for the length. The width would be decreased by 1, so 5. 3, and 4 would be the next two numbers. And then if I make my length 4, and again, it has to be natural numbers, so I'm confined to just picking these whole numbers. If length is 4, then my width is 3, and I've basically just repeated myself, because a rectangle that is 3 by 4 is going to be the same as a rectangle that's 4 by 3. You just have to rotate it, and that's it. And so I don't really need to keep looking for different rectangles that satisfy the problem. It's just these, well, technically these 3 right here that actually form rectangles that matter for this problem. So let's see, perimeter is still 14. Area here is 2 times 5, or 10. The perimeter here is still 14, and the area is going to be 3 times 4, which is 12. And that is going to be the maximum area for a rectangle whose sides are natural numbers and the perimeter is 14. So that is all from me today. You can say bye-bye to Quilly, and we will see you tomorrow.